All right, guys. So what we are going to be doing today is from chapter 8. We are going to be covering different powered functions. So in your notes, the very first thing that I give you is something called an odd powered function. Odd powered functions are anything where your highest exponent is an odd number. And what those look like is, let's say we have x. Well, that doesn't work. Let's try another one. X to the third, x to the fifth, even x, let's say, to the 99th. Well, if you graph these, what these graphs look like is this. They resemble some type of a little like sideways S. Now, I'm going to start off with something very simple. What I want you guys to do is graph on your graphing calculator, try and graph x to the third, x to the fifth, and x to the 99th. Look at the different graphs right now. So pause it, go ahead and try that. All right, so if you just tried it, what you're going to notice is the larger your highest x, your odd number of exponent, what happens is the flatter this gets on the graph, where x to the fifth is going to look a little like this. X to the 99th is going to look like this. It's going to go super flat and it comes down. What happens is, conceptually, this horizontal flatness, let's take an xy coordinate plane. It's kind of looks, x to the third is going to look like this. X to the probably like 11th is going to look like this. X to the 99th is going to look like this. What happens is this gets really, as it approaches the x axis, it gets really close, and then it crosses the origin, and then it gets close, it gets super close to the x-axis, to the positive x-axis before it goes up. Odd-powered functions resemble some type of a sideways S. And we're going to get into these a little more in-depthly in a little bit. Even-powered functions, the next thing on your graph, or actually let's stick with odd-powered functions. And it says, for example, x minus 2 times x plus 4 times x plus 3. All right. What that means is, if you were to multiply that whole thing out, you should know you're going to have your highest exponent as x to the third. And then you're going to have plus or minus something x squared, plus or minus something x, plus or minus, negative 2 times 4 times 3 is negative 24. All right, whatever. So you're going to have a big polynomial. Your highest exponent tells you whether the shape is like this, or I'm going to talk about even-powered functions in a second. But right now, x to the third, your highest exponent. So you know this graph's going to look like this. Now, if you look at the graph, if you were to solve using a zero product property, meaning set every x equal to 0, x minus 2, you would have a solution at positive 2 and 0. X plus 4, you know you're going to have a solution of 1, 2, 3, 4, negative 4 and 0. And x plus 3, you know you're going to have a solution of negative 3 and 0. Okay. If it's a positive odd-powered function, it's going to start low and then it's going to turn and go high infinitely. If it was a negative x-powered or odd-powered function, it would start high like this, and then it would eventually go low. It's just the reflection of this. It's just flipped over. Even-powered or odd-powered functions that are positive look like this. Negative-powered functions, for example, negative x to the third is going to start high and then it's going to go low. So if I were to ask you kind of guesstimate what the graph in red is going to look like, you should be able to tell your highest exponent is going to be x to the third. You should also be able to tell it has 3 roots. Positive 2, negative 4, and negative 3. If you set all those equal to 0. Now, what if I were to ask you what's your y-intercept? If you set every x equal to 0, you're going to have negative 2 times 4 times 3. which is going to give me negative 8 times 3 is negative 24. So you know this graph is going to go way down here. Let's just say negative 24 and the y-axis is right there. Now if you graph this on your graphing calculator, this is what it's going to look like. It's a positive. If you multiply that all of that out, it's going to be a positive x to the third. So that means your highest exponent tells you the most intercepts on the x-axis that it can have. So I know it has 3 intercepts. I know my y-intercept is at negative 24, and I know it's going to look like this because it's a positive x to the third. So if I were to ask you to graph it, you could guesstimate it and say it's going to look something like this. I don't know how far up it comes right here. I do know it comes down before it comes and it hits the y-intercept right here. It could go down way down here and then come back up. I don't know. This is a rough estimation. And that's all this lesson is just understanding the characteristics of odd and even powered functions. So if you were to graph this on your graphing calculator, I don't remember what it looks like graphing, but it should look something like this. Okay. The next concept is an even powered function. So on your notes, even powered functions. How do you know what the heck an even powered function looks like? It looks like a quadratic. It's either shaped positive like this or negative like this. It's facing downward. The graph in black is a positive. The U in red is a negative. So if I were to ask you, what are your x-intercepts on the first even-powered function example, where it says x minus 3 times x minus 10 times x plus 1 times x minus 1? You should know that on your graph, you're going to have an intercept at positive 3. You're going to have another intercept at positive 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should have another intercept at negative 1. You know, you're just graphing this normally. You're going to have another intercept at positive 1. Okay. You have 4 intercepts. That's the most you can have, because how many x's do you have? If you multiplied everything out, you would get an x to the 4th. Plus or minus something x to the 3rd, plus or minus something x squared. I mean, the polynomial will go on, but this is your highest exponent. It's a positive. It's not a negative. There's no negative in front of the x, so it's going to look something like this. Now, let's find my y-intercept. So if I plug a 0, remember whenever you're finding a y-intercept, plug a 0 in for your x, or substitute a 0 in for your x. So I'm going to have, if I substitute a 0 in for my x, I'm going to have negative 3 times negative 10 times 1 times negative 1. All right, so I'm going to have negative 3 times negative 10 is positive 30 times 1 is still 30 times negative 1 is negative 30. That's my y-intercept, 0, negative 30. Okay, so I'm going to get rid of all this mess right here, and I know my y-intercept is going to be, I'm just going to do it off of the grid. My y-intercept is going to be way down here, right here. All right, so now what I'm going to do is, I don't know if that comes off. Okay, yeah, it comes off, but whatever. All right, so I know it's going to start high, and it's going to cross my y-intercept here. I don't know how far it's farther down is before it bounces back up. I know that it has to come back up before it goes back down, because it has to resemble some kind of a U. It has to start high, it has to end high. It has to end infinitely going upward. So I know it's going to look like this, coming way down. Remember, my y-intercept is way down here, and once it crosses my y-intercept somewhere, it's going to bounce back up. I don't know how far it's going to go before it bounces back down, and I don't know. I mean, I could figure it out. Like, you could plug in a 8 into the graph and figure out what your y number is, but just kind of just estimating, because that's all this lesson is I'm just teaching you how to estimate the look of a graph. I know it's going to bounce back. I don't know where it's going to go exactly, but it's going to come back up here. I could figure it out, like I said, Let's take 1, 2, 3, 4, 5, 6. Let's take 6 for your x right here. If we truly wanted to figure out where we are at, somewhere around here, we can plug a 6 into the function and get your following y. It's going to be a negative y because it's going to, the way that it works, it's going to end up down here before it bounces back up. Anyways, this graph, it's an even-powered function. It's a positive even-powered function, so it's going to resemble some type of a quadratic. It's a weird little messed up quadratic, but it resembles some type of a quadratic. Okay. Now, I'm going to give you guys one to try. The blue example, it says x minus 4 times x plus 7 times x minus 8 times x minus 5. Pause it and do this. See if you can find the roots. See if you can figure out if it's an even or an odd powered function, and find the y-intercept and estimate what the graph looks like. Okay, now that you paused it, and hopefully you guys just tried it right now, you should be able to know what this graph looks like. So what I'm going to do is I'm going to create this graph. I'm going to do my intercepts. I have a positive 4. I'm going to have a negative 7. I have a positive 8. And I have a positive 5. All right. My y-intercept, plug a 0 in and figure out where you would hit the y. So if I plug a 0 in for my x, I'm going to have negative 4 times 7 times negative 8 times negative 5. All right, so I'm going to get a negative 28 times a positive 40. Negative 28 times a positive 40 is going to be way down here. It's going to be a negative big y on the y-axis. It's going to be a negative on the y-axis. I don't know what negative 28 times positive 40 is. It doesn't matter. It's going to be way down here. If you graph it on your calculator, you can figure it out. All right, but I know it's going to have 4 intercepts. If I multiplied all of that out, it's going to be x to the 4th. That's my highest exponent. X to the 4th. I'm just not multiplying everything else out. I don't need to. I just need to know my if it's an even or an odd powered function. It's an even powered function. It's a positive, so it's going to be curving upward. All right, now I'm going to graph it. It's going to start high, and over here it's going to end high. It's going to both be going up. I know, based off of the characteristics, it's going to go way down. It's going to cross my y-intercept way down here before it bounces back up. So it's going to go way down. It's going to cross, and it's going to bounce back up somewhere. I don't know how high it's going to go, but it has to go back down because that's the only way it can bounce back up. I don't know this point if it's up here, if it's way down here. I don't know this point if it's here or if it's way up here. I don't know. But I know my graph is going to look something like this. Okay. The next thing in black, I think most of you guys can probably figure out what this means when I say the minimum degree of the polynomial is the maximum amount of x-intercepts that it can have. So looking green, I give you a quadratic and I say, what's the minimum degree that this polynomial can have, that this graph can have? That's the maximum amount of x-intercepts that it can have. So what's the most amount of x-intercepts that this can have? Well, I can draw a graph like this. How many x-intercepts does it have right here? 1. If I were to draw my graph, what if I were to raise this up here? The 1, 2, 3. The maximum amount of x-intercepts is the smallest degree that this could be. This graph could be x to the 3rd. That's the smallest degree. I know it's an odd-powered function. It could also be x to the 300th. We don't know. But the smallest degree is the most amount of x-intercepts that you can have. So, for example, I'm going to ask you a question like this on the test. I'm going to say, what is the minimum of degree that this graph could be? Something like this. meaning what's the most amount of x-intercepts that it could have. So let's say here is my x-axis right here. I could have an x-axis right here, like let's just say here's my graph. There could be two intercepts, but what if I shifted this x-axis and I moved it down? I could still have an x-axis like this. This is the maximum amount of x-intercepts. 1, 2, 3, 4. So that's the smallest degree that it could be. This cannot be x squared. This cannot be x to the third because x to the third is an odd-powered function. This has to be a graph like this of x to the fourth. This could be x to the 400th for all we know. I don't know. All I know for sure, because you can have x to the 400 doesn't mean you're going to have 400 x-intercepts. It just means you could have a lot of non-real solutions. But I know for sure that the smallest degree that this could be is x to the fourth. Okay. Now, I'm going to ask you to graph x minus 4. The last thing on the notes, it says graph x minus 4 squared. Graph it. All right, you should know without even pausing it that the y-intercept, the x-intercept is 1, 2, 3, 4. If you graph it, that's your vertex, because that's in vertex form. So your vertex is 4, 0. Notice how it bounces off of the x-axis. Because if you had, it's called a double root. X minus 4 times x minus 4, you're going to have a double root. Anytime you have a double root, what that means conceptually is this is bouncing off of the x-axis. It doesn't go down and go back up, it just bounces off of the x-axis. If you were to graph x plus 1 squared, it would bounce off of the -1. What if I were to ask you to graph this? Let's combine both of those, and let's say f of x equals x. Let's just combine both of those. X minus 4 squared times x plus 1 squared. And I said, just give me an estimate. Estimate the graph of this. Well, you should know one thing. My root is 1, 2, 3, 4. My other root is -1. It's a positive because if I were to multiply this out, this is going to give me x squared, and this is going to give me x squared. So that's going to be x to the 4th. I'm going to have my highest exponent is x to the 4th. Okay. What's my y-intercept? Well, plug a 0 in. 0 minus 4 is -4. Squared 16. What's my y-intercept here? 0 times 0 plus 1 is 1. 1 squared is 1. 16 times 1 is 0, 16. All right. Now my y-intercept is at positive 16. Let's say it's way up here, positive 16. And I were to ask you to graph that. Well, it had a double root at -4. So that means it's going to go and it's going to, it has a double root at -1 and +4. I'm sorry. So double roots means it bounces. Boom! You know it's going to cross this y here. I don't know how far down it's going to go, but it's going to go boom and bounce up again. There's a rough estimation of the graph. Double roots bounce off. What if I had x minus 4 to the 3rd? What happens as I have x minus 4 to the 3rd? It's not a double root now. It's a triple root. Whenever you have a double root, or like x minus 4, x minus 4 squared, x minus 4 to the 4th power, x minus 4 to the 6th power, all that's happening is when it's going, as long as it's an even exponent, it flattens a little before it bounces back up. The smaller the exponent, when it's an even number, the quicker it bounces. The higher the exponent, let's say it was x minus 4, let's just do this to the 8th. It would look like this. x minus 4 to the 8th, graph it, and let's see what happens. It would go and it would get flatter, and then it would get boom and just cross it and get flatter again before it comes back up. It wouldn't bounce up as quick as x minus 4 squared does. Okay, but let's go back to my original thing. This is the last thing, is what if you have a triple root, because this is called the double root, and I think the book talks about triple roots, x minus 1 to the 3rd. Well, my root is positive 1. I know this graph is going to look like this. It's going to start low and it's going to go high. But what happens, how do I know it's going to start low and it's going to go high? Because it's x to the 3rd. It's a positive odd-powered function. So this is called a triple root. What happens is it gets flatter before it comes back and goes up. It hangs out, it just chills on that x a little longer before when it hits it, it crosses it, it chills a little and then goes back up. If this was x to the 13th, what would happen would be this. This is still, it's only going to have one root, but it's a 13th. So that means, here's 1, it's going to go and it's going to chill even longer before, boom, hits it, it goes, chills you longer the other way, bounces back up. So what happens is, it's not that drastic. When you graph it on your calculator, it's not, but I'm over-exaggerating so you understand. Whatever this root is, as long as there's one root, but it's an odd power, it just means it gets flatter before it hits that. What if it was x minus 1 to the 3rd? It just looked like this. It would just get a little flat for a second and bounce back up. To the 13th, it's going to look like this. It goes flatter a lot quicker, and it gets closer as it approaches the x-axis, and then once it hits it, it still stays a little y value before it bounces back up. Okay, so that's the lesson, and your the notes in your lesson is right below.